Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rules in computing the derivative of this given function involving trigonometric sign. So we are given here with a unique function. You have f of x is equal to 50 sine x all over x cubed. Since we have here a quotient of functions, we are going to use here the rule in differentiating quotient of functions, or also known as rational functions. But basically, I have here on my numerator a presence of sine trigonometric function, hence we'll be using the said rule. First, you can apply here representation saying your numerator is g of x and your denominator is of course h of x, but h of x cannot be equal to 0 per the needed requirement of the rule. Now, let us remind ourselves of the quotient rule. Yes, we will touch later on sine, but in this first place, we are going to start with the rule on quotient, or the rational functions, deriving rational functions. Your first derivative is just here. Please not interchange the numerator. You copy the denominator. And by the way, I might confuse you with some of the notations previously presented. So I will be changing this into other variables, let's say k and m. So m here, so that you will not be confused. M, copy the denominator, take the first derivative of the numerator, minus the numerator, and then you have here the first derivative of your denominator. Take note that for this entire numerator, the operation is subtraction, hence they cannot be interchanged. So you need to stick with what is really the correct form of the rule. Okay? Unlike the product, where the operation separating two pairs of terms being multiplied is addition, where you can simply interchange them. Here, you cannot do that. Over the square of whatever it is on your denominator. Here's the rule. But of course, we're going to look into it step by step, as we have our k of x here being a numerator. That's actually 50 sine x. Hence, we need this because that's part here. So as we take the first derivative of 50, you will use here the idea of constant multiple. Here's your constant and here's your trigonometric function. Hence, you copy that constant and derive your sine x. The rule of deriving sine x is simply equal to the positive of cosine x. A proof of that is also presented in this playlist. Please review that on your own time. Hence, simply place your cosine x, which will give us 50 cosine x. That's 4k prime of x. As for m of x, it's actually x cubed. So we just simply need to use here the rule of differentiating a power, as we take the first derivative of m. So you will just use your n, that's your n is a 3, x to the power of n, which is again 3, minus 1. Hence you will have your 3x squared. Now that all of these are now completed, let's proceed now to the first derivative of the intended function identified here. Let me move this down a little bit because I might need a lot of space, as I would include here rational expressions. We will start according to the rule m prime of x, which is identified as x cubed, this one here, times the derivative of your numerator, which is 50 cosine x. Let me rewrite this. This is 50. Okay. I don't think if it's the space is enough, but let me try. Minus, again it's minus, your k of x is 50 sine x times, you will have the derivative of your m of x, which is 3x squared. Pardon of the spaces, I'm trying to complete this without moving to the next page or the bottom portion. So here, take note, I am multiplying this entirely, because if I will not place the parentheses earlier, I might be confused with this only. So I am multiplying the entire form all over. Again, your denominator is original is x cubed, so you need to square that. Okay, I will still move here. I don't have much space. Simply rearrange them. 50 x cubed cosine of x minus 50. Sorry, that's not 50 because I have 3. So 3 times 50, that's 150. That's here. X squared sine x all over. You have your x to the power of 6. Supposedly, this is already okay. However, if you are required to simplify, you really need to simplify because you have here x cubed and x squared, and something can be simplified here. So you factor x squared on both terms on your numerator. You'll have here 50. As you take out x squared, you only have x cosine x minus 150, but you already factored this out, sine x, sorry, all over x to the power of 6. We're doing this because if we can simplify, we need to simplify. You will use here the proper laws of exponent. Your final answer for the derivative of this given function is 50x cosine x minus 150 sine x all over x to the power of 4. This is the result for the given function here, which is 50 sine x over x cubed. So again, we applied here a process of factoring to simplify it further. But first and foremost, we use here the rule for quotient. We also have for sine, and of course, other rules such as multiplication and such. Thank you very much for watching. So what are you waiting for? Subscribe now.